Okay, if you're watching this later, I'm just setting up the stream early today in order to make sure things are working. It's actually 8:45-ish, 8:46 actually. So if you're looking for content, things are going to get started at 9 o'clock. Okay, I need to turn off the sound over there. It's going to get confusing to hear the two different streams. Anyway, as I was saying, at 9 o'clock I'm going to start doing the class information and the lecture, so you may want to skip forward on this. Actually, you can ignore all that because I'm not recording yet, so I will be recording soon. Good morning, Joel. I'm not recording yet, but if you can hear me, please put something in the chat so I can make sure that the sound's coming through. Okay, I wonder if that meant that you didn't hear me. I don't know. We'll see. Hopefully, sound is working. I'm not sure if there's a good way for me to check or not. Okay, that's good information, Joel. Are you sure that your sound is turned on, correct? Let me see if I can check on a different device here. Good information, Joel. Are you sure that your sound is turned on, correct? Let me see if I can check on a different device here. Yeah, it looks on my other computer here, I'm able to hear the sound, so I'm not sure what's going on. Yeah, it looks on my other computer here, I'm able to hear the sound, so I'm not sure what's going on. Okay, good. Glad that you can hear me. So we've got one person here, and technical issues seem to be working okay. And my allergies are killing me, so I'm going to be, unfortunately, coughing the entire session, sadly. One thing we can try, Joel, since we have a little time before we get started, it's, again, as I mentioned in my email, one of the problems is that it's a compromise doing it this way. By doing it through the YouTube live, I'm able to record them in case students have to miss, and I know that some people have some scheduling issues. The downside is I don't get the interaction which you normally get through Google Hangouts. So on my other computer here, I actually have Google Hangouts turned on. So if you want to open up a different window to plus.google.com, there should be a button there where you can start a Hangout. And if you want to start a Hangout with me at the frazierde@gmail.com, then that'll pop up also. That may totally confuse the world. We may get horrible feedback, but I don't know. We could try to see if it works. What I may actually do after I give the normal lecture part where you can chat if you have any questions, I may shut down the feed and move to Google Hangouts for the discussion part of the class, if that makes sense. So, I mean, it's nice to be able to hear you guys when you have a question, but it used to be that you could record Google Hangouts, but that's no longer the case. So we're going to have to do things a little bit differently. If anyone else gets on, make sure that you say so in the chat box so I know that we have people here. Okay, I don't have any email from anyone, so I'm not sure if people aren't up and around yet or what's going on, but still have about 8 minutes. So I'm just going to wander around a bit probably, so you may see a blank screen, but okay, Arnold's here, good. Arnold, your email address didn't work when I tried to add you to my circle, so if you can send me an email from that account again, that would be a good thing. Wish I had a mute button. I don't know if I do or not. I don't seem to. There doesn't appear to be a mute button anywhere. I'm also unfortunately looking at several computer screens, so I notice on the when I'm looking at the delayed version, my eyes are darting around in a crazy fashion, and that's what's going on. Once we start lecturing, hopefully I'll be able to go mostly on one as opposed to multiple computers. Although we'll have to look for there to be any chats. The time delay is very interesting because on the computer that I'm speaking into, I'm seeing myself live. But on the computer to my right, there's about a 6-second delay. So it's quite interesting to see that happening. I think I like that camera angle better. A little bit more of a straight shot. Okay, Arnold, I did get your email with your new address, or different address apparently. So I will get that added in at some point. That should work. See if anyone else is here. Looks like not. Still have some time. Just as a heads up, we're going to be going through some stuff on Moodle, the syllabus and the class schedule, and the big project this class has. So if you want to, you can go ahead and open up a new window and get Moodle going. That wouldn't be a bad thing at all. Save some time later. Good morning, Mandy. Okay, the address for the Google Hangouts, I'll type it as well, but it's plus, get the keyboard working here, plus.google.com. Okay, and again, I'm on two different computer screens, so if you wonder why my heads and eyes are darting around in a funny fashion, I'm not on amphetamines or anything, just caffeine. I'm just trying to watch the two different screens as we go along. All while my nose is itching and I'm coughing and my allergies are killing me, but such is fall in Tennessee. So it looks like three of you are on now. It's a good thing. Got a couple more minutes, and then I will start. Just so you guys know, if you happen to catch the stream late one day, you should be, at least they say this, you should be able to back up the live stream, kind of like a DVR, and go back to the beginning and start from there. Okay, so that could be worthwhile. We'll have to see. Again, I apologize for coughing. I will look for a mute button somewhere. I don't see it right off. Okay, we're going to go live in 1 minute. I mean, I guess we're already live. I'm going to start recording in 1 minute. Okay, so I won't say anything else till then, because then I'll just have to repeat it. Hey, Steve, glad that you're on. Going to get started here in just a second. Okay, I have 9 o'clock, so I'm going to go ahead and start the recording. Okay, we're going to go ahead and get started. I think everyone's not here yet, but that's okay. Again, if you're ever late to a session, you should be able to back it up like a DVR in order to see what you've missed. Okay, these are also going to be available. If you go to www.youtube.com/user/FrazierDE, that's my YouTube channel. And after today's session, the video should be there. And as I understand, everyone we do will be there. It'll certainly be there until we do the next one next week. Okay. So today I do have a lecture planned, even though this is an online course. I think it's important that I get a chance to talk to you guys and somewhat interact. Online education has its place. I really like in class. I think that's where we do best. but the world doesn't work that way, so it's perfectly okay. But I think by doing the video, it should make some sense. Okay. So again, I'm going to be checking over. You'll see me move my head around. I've got two screens. When I see the chat window, I'll keep checking for that basically. So if you have questions along the way, go ahead and do that. And again, as I mentioned to some of you earlier before I started recording, this is kind of a compromised position using YouTube. Google Hangouts used to allow for the recording of the sessions. They don't do that anymore. So I think the general plan here for this class and for others if you take from me is that I'll do the lecture portion where the only way you can interact is through the chat. Okay? And then at the end of that, there'll be the opportunity for you to get onto Google Hangouts. Google Hangouts, again, are at plus.google.com, and there's a Hangout button there somewhere, depending on which browser you're using. Okay, and if you do that to the FrazierDE@gmail.com address, then that'll pop up, and we can do an interactive session where I can see you and you can see me. Okay, so there are great advantages to that, but that part will not be recorded. Okay. So again, let's go ahead and get started. Sorry, my eyes again are darting around. I've got two different computers to look at here. So let's start by going over the course syllabus for this course. Okay, everything's on Moodle, so you should be able to get things. If for some reason things are not on Moodle, make sure you let me know. Moodle sometimes does funny things. So this is a new course for the GPS. The Advanced Information Technology concentration has been redone to make it all online. I've taught it for a couple of years, I think 3 years now, where it was partially online, partially not, or a hybrid course. And the enrollments were just not what they could be. I kept hearing students would say that, well, other people I know in the GPS program in my cohort or in my classes would like to take this, but it's not online. The other ones are. So we're all online now. So this will be a little bit different. So it won't be exactly the same as it has been. So there may be a few glitches along the way, but hopefully we'll work them out. So this course is a new one. It's called Core Web Technology. It's Computer Science CISC 305. The purpose of this course is to just cover the basics of how the internet works, how networking works, and then we're throwing in some database. Database used to be a standalone course, but we found that a lot of the students that are taking this concentration didn't really have the programming background necessary to do a whole course of database. Okay, so we're going to get database light, so to speak. Okay, this course in particular used to be taught on campus. It wasn't hybrid. It was on campus for all 5 or 6. We used to have 6 meetings, doing some hands-on. There will not be hands-on networking in this class as well. Okay, so again, this class we're going to talk about how the internet works, how networking works, how databases work, a little bit of how to interact with the database. Okay, and the main takeaway from this course, we're going to be doing a project, a group project, with 2 or 3 people per team that I'll talk about in a little bit. Okay. So again, this course is an online-only course. We will do this video lecture every week, assuming the technology doesn't fail us. If not, we'll find something else. In addition, I will take an email poll to see if there's one night during the week you would like me to hold virtual office hours. So for a virtual office hour, I would be logged into Google Plus, and you could start a Google Hangout with me if you had any questions. More of a one-on-one type of a thing. Okay. I also have regular office hours if you're near Greenville. My office hours during the week are Monday through Thursday from noon until 2:30 every day, except Monday through Thursday, like I said. I'm around other times. I can meet other times. So if you know you're going to be in town, let me know. Okay, so this class normally, and again, I'll check via email, see if anyone has any issues with that. It's supposed to go, I think, from 9 to 1 or something crazy, but since we're doing online, we're not going to have that much in-class work, okay? So the lectures I gave are typically, I would say, about an hour, and we usually meet at 10 instead of 9. So just because we don't want to get up as early. So again, I will send out an email, and we'll see if that works for everybody. I'm okay either way. I'm an early bird. Again, as far as course materials and the text for this class, there is no text, okay? The only information you're going to get is going to be through the lectures. I will release notes about what we've talked about. Okay, so lots of good resources online. I may occasionally point you to web resources for more information. If there's a topic that you feel that I haven't covered enough, it may be, a lot of things are going to be outside of the scope of this class. Feel free to ask me about it, or you can Google it. Lots of information. Okay, I will always explain things again. If you're chatting with me right now, I can't see it yet because I'm looking at syllabus, but I will check back in a second. Okay. The grading criteria for the class, the research paper. We'll pick a research topic about networking of some sort or database. We'll talk about that in more detail next week, and I'll put something on Moodle. It's 20% of your grade. Homework assignments, there'll be a couple of those, most likely, are worth 20%. There will be a final project proposal, again, with you and your team. You'll put together a document, a formal specification document of some sort, kind of saying what you want to do. The final project itself is worth 30% of your grade. And then the final project presentation, which will be done via Google Hangout, is worth 10% of your grade. Okay, the scale's pretty normal as far as that goes. Not really, a big deal on that. Okay, the rest of the syllabus is fairly standard stuff. You can look through it, and if you have questions, feel free to ask. We'll see if there are any questions. Looks like there are no questions. Okay, I know I'm on a delay here, so if you do get questions, let me know. Put them on the chat, and I will answer them as we go. Okay. So if I don't hear any questions, I'm going to go ahead and go on to the schedule. Okay, the class schedule. Okay, the class schedule's on Moodle as well. As it says there, it could change. That's a possibility. So you want to make sure that you keep up to date. It's probably not likely to change. We don't have that many things, many sessions to deal with. Okay, but the dates are today 8/22 through 9/19. Okay, and today we're covering the OSI model and the internet infrastructure. Okay, next week we'll talk about networking hardware, switches, routers, things like that, how to hook up a network. Again, we can't really do networking. So we're going to have to kind of rely on talking about networking instead of doing it. Okay. Week 3 on September 5th, we will talk about the database basics. How databases work, what some of the options are. We'll talk about the structured query language, or SQL. SQL is a common language among most, if not all, database systems you're going to run into. So it's a query language, which means it's a way to retrieve information back from the database. So that's really what we'll talk about. Okay. Week 4, on the 12th, we'll talk about security. Security in any network situation is really important. The internet opens up your business and your resources to the entire world in ways they did not before. So it's important we talk about security. As part of that, we'll go through a formal threat analysis procedure. So ways to make sure that your business is doing all that it can, in order to keep the information that people entrust to you safe. Okay. And then on 9/19 will be the final project presentations. So the final projects will be due. Those will be due through Google Drive. Again, if you go to drive.google.com, you log in just like you do for Gmail and everything else. Once you have a Google account, you have access to a whole lot of different resources. So you will create this formal presentation, and there are different parts of that we'll talk about here as we go along. Okay. So let me again check for questions. Looks like no questions yet. There are more people here, it looks like. That's a good thing. Okay, so let me check over here. The final project, it looks like I have not put on Moodle yet, and I apologize for that. I will go ahead and do that this weekend, but I can talk to you about it a little bit because I do have the write-up already. Okay. So again, the final project in this class is going to be to work with 1 or 2 other teammates. There are currently 11 people showing up on the roster. I haven't heard from a couple of those people, so I'm not sure they're still really here. But the ideal thing to do is to have 3 people per team. But at 11, one team will only have 2. So we'll do a combination of 2 and 3 people in order to get that to work. Okay. So the final project is going to be to do a network analysis on a fictional business. Now, in the past, students have picked typically businesses that they're either actively thinking about starting or have always thought they would like to start. Okay. Now, with 3 people, you can't all do that, but hopefully one person in your team has a little bit of knowledge or a little bit of interest in one area or another, and you can go ahead and create a business that's more realistic. That's usually easier to work on those kinds of projects. That is not required, by the way, but that's just something to think about. So the basic goal of this project, you're going to create a network plan that has a list of hardware and software you're going to need, all of the ways you're going to connect them together, all that stuff. Okay. So there's some requirements for the business that you're trying to create. There should be at least 100 employees. They should be working in at least 3 separate physical locations. Those physical locations do not have to be separate buildings. They can be separate rooms in the same building. And that's going to make a difference when you're looking at the network diagram and how you lay things out. You'll have to not just put 100 computers in one room and run wires between them. You'll have to figure out how to get the connection from room to room. Okay? So each employee, and again, all this is written up, so you don't have to worry about this now. I'm just giving you an overview. Each employee of those 100 will have a computer that has an Ethernet card, so you don't have to spec those out. So don't be pricing computers or Ethernet cards. Most computers have Ethernet cards built in. Okay? So this business is also going to need to have a web server. That web server needs to be running Apache's web server software. Okay, so that's relatively straightforward. It's also going to need to be running a database server running the program called MySQL. Okay, that's a freeware package that's now owned by Oracle. Oracle is one of the big dogs in database world. Okay. So as the assignments go along, this is just the overview. You'll have to look for server space where you can rent server space to make sure it has the specs that you need, things like that. Okay. So again, as far as the equipment goes, you'll have to figure out which exact equipment you'll need, what the cost will be. You'll look it up online. You'll give me the URL where that equipment's located and how much it costs. So you'll need at least cables to connect the computers to each other. You'll need switches, routers, anything else you may need, any software, if there's any recurring support costs there, and any security hardware or software you're going to need. Okay. So again, by the end, and these things will be due throughout the course, you'll need to have a network diagram, which is done either in Word or in some kind of drawing package. Again, if we're using Google Drive, which I recommend, there's a draw.google.com. I think, no, that's wrong. Actually, there's a drive.google.com. Click on Create New Drawing. That is a drawing tool that's online that is worth looking at. You'll also have a parts list. Again, the assignment says in Excel, but I would do it in, again, the spreadsheet portion of Google Drive. Makes the most sense. Okay, and that would be all the cost associated with your network plan, except, again, the PCs and the network cards, which we assume are already there. Okay, and then you also want a narrative plan, or a narrative description of your plans for the business. So you start with the description of the business that you're modeling. That'll be one of your homework assignments to get that going. And again, you're making this stuff up. So when there is real information, Google it and find it out. The stuff that you don't know, I mean, you have to have 100 employees. You don't have to find 100 people who are going to be your employees. Okay, you can make up the names if you need to do that. Okay, and then the last thing you'll need on this will be a description, a step-by-step plan on how you're going to secure the web server, the database server, and the users of the network. Okay, so let me check again for questions. And again, if you're new, I'm sorry, my eyes are darting back and forth. I've got 2 computer screens going here. Okay, still no questions, so that's okay. I assume that I'm still live. My little things here say that I am. Okay, so that's really it as far as the class information goes. So if you have questions about any of that, please type them in the chat box or send me an email at some point. I can answer them now if you send that along. Okay. So today I'm going to go ahead and start the first lecture. Okay. And again, along the way, please ask questions. It's easier to deal with things, as they happen rather than afterwards. Okay. So I know there is a delay of several seconds, so I may have to backtrack a little bit. Perfectly okay. Okay. So again, we're going to start today talking about the internet itself and networks in general. Okay. Networks have not always been here, obviously. It started off when computers were new. The concept of a computer, you'd have this giant room-size device that people only at that physical location were able to connect to. So that worked well enough. A lot of it was a Defense Department. They were so expensive, excuse me, that only the Defense Department would be able to afford it. Okay. Okay, somebody has a question about when classes are going to start. Yeah, I'd mentioned that before, maybe before you got on there. It doesn't really matter to me. We can talk about that via email. Okay, so we'll do an email thing on that. Okay. So at least I know I'm still live, I think. Okay, so anyway, in this environment, computers were not connected at all. People didn't have their own computers. This was back during the Cold War, which some of you probably are old enough to remember, those glorious days of the threat of nuclear annihilation. So it became clear that from a security standpoint, these large computers that the Defense Department was hosting were big targets for a Soviet missile. Okay, so the idea became, let's connect these systems together to allow redundancy. Okay, and that's still one of the things that we do with the network. The network is the internet itself, it would be hard to take down the internet as a whole because of the way it's put together. Okay. Unfortunately, the internet was not put together with regard to security, particularly because they really weren't connecting it to anybody they didn't know. If you were on the internet probably prior to the 90s, people knew exactly who you were. Okay, it was not open to the public in general. Okay, so we've moved from these standalone systems to what we call distributed systems. So a distributed system is just one that the computers are connected together. They can share information. Okay, we take that for granted today, but it really is quite extraordinary. I was working at the University of Michigan when the internet first really hit public usage. This is before the web, and it was just a whole new world. It's quite amazing that we don't often think about how important that is. Okay, so next we're going to talk about the uses of computer networks, or where these happen. Okay, lots and lots of business applications. One of the main things is resource sharing. I remember that PCs came out. They started hitting in business as soon as I was kind of getting into the business world in the late 80s. Okay, one of the big things that was expensive then were laser printers. Laser printers were horribly expensive. So therefore, a department wouldn't want to buy laser printers for everybody. That was crazy extravagant. So instead, they would hook up a network of these PCs in order to share the resource of the printer. Okay, and it's still true that resource sharing, it just makes sense. Whether it's printers, whether it's shared disk drives, whether it's scanners, other kinds of specialized equipment, you can use a network to share that. Okay, networks are also very useful to create virtual private networks. It's a way to allow someone remote, one of your employees that's at a remote location or at a conference or at a sales call, to be able to connect in via secure channel, an encrypted path through the internet, in order to get onto their home computer or their computer in their office and get onto the network. Okay, so those are always good things. Okay, a lot of the internet works on what we call a client-server model. With a client-server model, you have a dedicated, always-on server that the other computers are going to act as clients to connect to. The web works that way. Databases work that way. Things like that. The other option would be peer-to-peer. So there are situations where computers are either the server or the client, depending on the transaction. Okay, some of the music sharing sites that were popular a while back and still are, I'm guessing, would fit that peer-to-peer model. Okay, email, of course, is the real early killer application for the internet. People really wanted to use email. That's become very common today. Okay, it's also possible to get VoIP or voice over IP. If you have Vonage or something like that, then you can certainly do that. Desktop sharing is certainly something you can do. Google Hangout has that option. I don't think that the YouTube has that, but we certainly, if we're doing a Google Hangout, if you're having a problem with your computer, you can share your computer screen with me, or I can share it with you. You can also do as we're doing now and have virtual meetings. With the virtual meeting, I didn't have to get up this morning and drive to Morristown. You didn't have to get up and drive to Morristown. And that's even worse when you're talking worldwide businesses. You can have meetings where people are located all over the world. Okay, is it the same as being in person? Not really. But it's better than nothing and often gets the job done with much less cost and much less time. Okay. Also, e-commerce. There's a whole class you'll take in e-commerce. We won't talk about it much here, except to say that e-commerce can be either the business to consumer or consumer to consumer, such as eBay, or business to business, such as part of a supply chain organization. Okay, it could also be the peer-to-peer again, which would be like the music sharing. Okay, there are also lots of things for your house that you can use the network for. Of course, you can connect to all kinds of remote information services. Pretty much anything you want to find out nowadays, you don't have to question anymore. I mean, before Google, Google wasn't the first, but before the internet, if you wanted to know what was the name of that movie or whatever, you couldn't. Okay, so there's all kinds of information resources. And beyond the trivial, there's really good information out there on medical issues. You have to be cautious to make sure you're getting good information, but it's out there. There's information on how to fix your computer, how to fix your house, how to fix your behavioral problems of your kids or your animals. Okay, so there's lots of stuff out there. Again, you need to be a good consumer of that information, make sure it's valid. There's social media, which is both a boon and a bane for the world. Okay, we can connect with people that we haven't seen in years, but one can question the level of that connection and whether it's all that good. Okay, email, of course, individuals do. E-commerce from the home application is that you can buy things that are not available in your local market. You know, I'm a big fan of of Amazon myself. I get all kinds of stuff from there that I couldn't buy here in Johnson City. There's also entertainment. Most nights you'll find me watching Netflix or Amazon Prime or Hulu. Those are all giving us, lots more entertainment options than we used to have, and have really come along in quality. Okay, you're starting to see a lot of people cutting the cord from cable now. You can get HBO and Showtime both have apps you can buy independent of having any cable. So it's really getting amazing. And there's a new service called Sling. I think Sling is like $20 a month, and you get like 10 cable channels, HGTV and Food TV, things like that come through the internet rather than through your cable company. So cable companies are not happy about all this, obviously. Okay. There's also, in business, you'll see the RFID, or radio frequency identification devices. And that means that if you put a package together in Tuscaloosa, Alabama, you can put a chip on it. And then instead of someone having to track it manually, there are sensors at the exits of the businesses that kind of track, that read that little RFID chip, and you know exactly where it's located at. If you ever do any package tracking on your system, then you're going to know that's where that's coming from. Okay. The big thing these days is that everything's moving to a mobile platform. Okay, so you're starting to see less of people carrying laptops around and using desktop computers. People are instead using tablets and phones. Okay, so from the business perspective, which is this is your business students, so you have to worry about this. You have to be aware of and make sure that you're dealing with the idea that some people are on very small screen devices. Okay, so they're not near as big as before. So again, I have my little iPhone here, which you'll see that doesn't have a lot of screen real estate compared to a big computer. Okay, so there are issues there as well. We have to talk about security issues and other things. Okay, there are some social issues that relate to internet and network technology. Okay, the big thing you hear in the news a lot is network neutrality, and we may talk about that a little bit more later. But the idea basically is, does your network provider, which is often your cable company, have the right to sell faster and slower traffic to the internet? Okay, so if I am Google, can I pay so much to Charter, for example, to get my customers that are going to my website quicker access than if you're Bing or some other kinds of thing? And the big issue there is, are you restricting access to smaller businesses when this happens? Okay, so that's still up in the air. Currently, net neutrality, in that the ISPs have to treat all of the different bits of data equally, is the law of the land. That can always change. Okay, lots of privacy issues that we'll talk about on Security Day. People are tracking your information. It's just a fact. The government is, businesses are. I'm sure you've had the experience of you'll go to Amazon and you'll look up lawnmowers. Then you log onto your Facebook, all of a sudden there's an ad about lawnmowers. So clearly your information, some parts of that information, are being tracked and kept and sent back to you. Okay, so you have to worry about these things. there's good and bad in all of that. From a business, there's probably more good. You always have to worry about hacking. I mean, people from all over the world can get into your systems. If I, before the internet, if I wanted to steal $20 from you, I would have to find you and then physically remove the $20 from your pocket. Okay. Now I could be halfway across the world, and through the computer, I would be able to reach in and take often much more than $20. Okay. And depending on the country that I'm in, when I'm attacking you, there may be little or no chance I'm actually going to get caught. Again, more on that when we talk about security. That'll be Security Day. Okay. The networking hardware we talk about next week. Okay, so that's just another area of networking. We won't talk about that much now. Okay. So as far as the networking software goes, that's how we make all this stuff happen. And a lot of what we're going to be talking about today is going to be this thing called the OSI model. The OSI model is a standard framework for talking about the internet. Okay. So as part of that, we have protocols. So protocol is a good term to know what it means. Okay. A protocol means simply an agreed upon way of doing things. Okay. In the computer sense, it means an agreed upon way to transfer information. Okay. So the internet developed in a way to be vendor neutral in essence, which means if I have a Linux computer, if I have a Windows PC or a Mac, it doesn't matter. I still get onto the internet. And I do that by using these agreed upon protocols. Okay. So when we talk about the OSI model here in a minute, there are protocols at each of those levels that I'll probably talk about. Okay. Those are not the only protocols that exist, but because the internet is everywhere and because the costs are so reasonable for people to be able to get on, that's kind of what's become the standard. Okay. So when you're thinking about this problem of networking, it really is quite a problem. You have literally millions of computers in the world that are connecting onto this global internet system. Okay, so there has to be ways to manage that situation. Okay, and it doesn't work perfectly. And again, security wasn't often the main design goal, sadly. Okay, but the basic strategy that was used is divide and conquer. Okay, so every computer is connected to a local network of some sort. Now that could be a literal local area network or a LAN in a business situation where you and all of your coworkers connect into the same router. If you're at home, then you're either going to be, most likely going to be on either a cable modem or a DSL, a digital subscriber line from your phone company. Both of those are going to connect in, again, into a local, sometimes a little bit bigger local than your business would be, network. Okay. Those networks then get their service from a higher level network provider. Okay. So we usually refer to the local area provider is the tier 3. And when you move to a tier 2, that becomes a regional provider. Okay, so at Tusculum College, we get our local internet from, I forget, it's from some company out of somewhere in Knoxville, maybe. It seems like it's Knoxville. That provider in Knoxville gets their service from a tier 2 internet service provider in Atlanta. Whoever that is in Atlanta gets theirs from a tier 1 provider, which is the global providers such as AT&T or big companies like that. Okay, so it's kind of like a highway system where every community pays for their part of the road. Okay, so you pay, the local organization pays for their little part of the internet. Okay, and by paying and maintaining their part of the internet, they get to use the whole thing. Okay. So this OSI model, it breaks up the problem of networking into different layers. Okay, we'll talk about the layers in a second. But the basic idea is that at each layer, you can assume certain services from the layers above and the layers below. And it just makes it easier to write software. So if you're going to write a new email program, okay, there are existing protocols in place to get you all the way up to the application layer, which is the top layer, okay? Which means you don't have to write how to deal with all the different Ethernet cards that are available, okay, or whether they're on wireless, okay? So again, by having the layers, just it furthers that divide and conquer idea, okay? So it's important that the layers have this interface. In computer terms, an interface is just a connection between the layers. Okay. So I guess before we get too far, I'm going to go ahead and type on the chat window here what the layers are at the first. Okay. So the first layer is called the physical layer. Okay. That's basically, and we'll go into much more detail in a minute, that's the wiring and the physical parts of things. Okay. Next, you have the data link layer. The data link layer is going to happen on the Ethernet card or whatever network card you're using. Okay. Layer 3 is the network layer. The network layer is responsible for computer-to-computer connections. Okay. Layer 4 is going to be the transport layer. Transport layer is responsible for connecting a process on one computer to a process on another computer. Okay, again, we'll talk about all this later. 5, 6, and 7 are often combined together, but layer 5 is a session layer. Layer 6 is a presentation layer. And finally, layer 7 is the application layer. The application layer is a protocol that's going to be used by the end user. It's going to be something like HTML for websites. Okay. So it'll take a second to catch up, so I'll make sure that you guys can see that. Okay, so those are the basic OSI model layers. Okay. So the design issues, when this was being put together, what the concerns were, you have to worry about errors. Okay, you can't assume that the internet is going to, or the transmissions are going to be error-free. Okay, you can't. That's not realistic. So you have to have a way to detect and correct those errors without having to take a ton of time. Okay, and again, there'll be more detail here in a minute. You have to be able to route the information from me sitting here in Tennessee, if I want to send an email to a friend in California. There has to be a way to get that there. The same thing when you're going to visit a website that's located in New York. You have to be able to find a way to route those packets. Okay. You have to have a way to address every device. Has to have a unique address. Okay. You have to have flow control, which means you don't want to send too much information. Okay. So if you're sending information, we often try to visualize network data as water in a pipe. Okay. If you have a 3-inch pipe, it has a certain amount of water that can go through it. Okay. If you send it more water than it can handle, it's just going to spill out. Okay. So that's the idea of flow control. You have differing levels of quality of service that you need. Okay. If you are dealing with an email, then it can be up and down. It's not such a big deal. Okay. Even if you're dealing with loading a website, okay, if it comes and goes in quality, not the end of the world. But if you're dealing with streaming video, or you're watching Netflix, or again, that streaming video, or a virtual meeting like we're doing now, if your internet is slow, it's going to appear as jaggedy email or jaggedy images, which could be a problem. Okay. So the big design decision here comes with networking with a connection-oriented or a connectionless model for networking. Okay, the connection-oriented is very much the idea that one computer connects to another computer and it knows the connections there. It's a persistent connection. Okay, there are advantages to that in that you know more what's going on. You have more reliability potentially. The downside is that it can waste a lot of resources because you're setting up this whole connection that you're not using. So, for example, the phone system, especially a traditional phone system, uses this setup. So when I call someone on the phone, it's going to create this bandwidth connection between me and the other end. If I'm not saying anything, that bandwidth is being wasted. Okay. So the other way to go is through a connectionless system. Okay. So with that, it's going to be more like the postal service, where you're going to drop something in and it shows up eventually. Okay. In particular, on the internet, all of the information we're sending gets divided up into what we call packets, smaller subsets. Each one's addressed, each one's sent out onto the internet, and it each finds its own way. Okay, if you've ever seen a pachinko machine with the little steel balls that fall down with all the posts, that's what I always think of with your messages getting through the internet. Okay, so your email message may have 25 packets that it's split up into. Those are all sent on the internet. They all make it through however they can. Then they all arrive and get put back together on the other end. Okay. So again, this OSI reference model, again, we're going to go through the layers together, or each one at a time. So the layers were created because there needed to be a different abstraction. And abstractions where you just make a mental model of something that makes it easier to talk about. Okay, that's what was done here. So each layer needs to have some well-defined function that it does. Okay, and the function of each layer is dependent on the other layers. So if we're working with layer 4, the transport layer, it can assume certain things from the network layer, and it can assume certain things from the session layer. Okay, so once the software is built, or once the layers are built, then you can traverse through the OSI layers, and there should be some consistency there. It's also important that you think about, when you're designing these layers, an eye to standardization. Okay, you don't want to have each manufacturer having their own set of protocols, or there's all kinds of trouble. Okay, so again, starting from the physical wires, the physical layer is the first one, the data link, which happens on the Ethernet cards, the network, computer to computer, the transport, process to process on a computer, and then session, presentation, application all happen on the end user's computer. Okay, so that's what we think about there. Okay, so I will give this a second here. I'm going to wait until my video catches up by listening here. And if you have any questions about that so far, let's deal with those before we get into the individual issues. Okay, I think we're caught up again. Okay, so let's go through this listing here of the different layers. We're getting a brief overview. My mouse will quit misbehaving. Apparently it's not going to quit misbehaving, so I'm just going to go on without it. Okay. So let's talk about the physical layer first. You can go either way. You can start an application and go up, but we're going to start at the bits on the wires, we call it. Okay. So again, the job of the physical layer is to move the raw bits of information. Okay. We haven't talked about it yet, but everything on the internet eventually gets reduced down to ones and zeros. Those ones and zeros are represented as high and low voltages, or in the case of fiber optics, they're pulses of light. Okay, so the job of the physical layer is simply to allow the movement down some wire or some system, some path of those bits. Okay, so when you're writing an email program, you don't have to care about how the bits are going to get transferred. Okay, that's not your concern. Just know that it happens. Okay, so there's a lot of complex things happening at the physical layer. A lot of heavy lifting in math, a lot of design issues that are kind of beyond the scope of what we do in computer science. Okay, as a matter of fact, the physical layer is typically electric engineers work on this. Okay, it's not something that computer scientists do. Okay, so all we care about is that the networks work. That's good. And that there's a limit on the bandwidth. The bandwidth is basically how much. Okay, technically, this is a bad definition, but the practical definition of bandwidth is that it's going to be how much information you can push across a certain connection. Okay, so again, think of the water pipe. Every water pipe has a certain amount of water it can carry at full capacity. Okay, so that's bandwidth. That's what's important. Okay. The bandwidth on any given media is typically going to be theoretical. Okay, if you ever had a modem, you'll know that you don't get the full amount. That's the theoretical maximum. There's usually other things going on. Okay, The only thing, well, there are a couple things in this layer. There are two basic types of media that we talk about. There's guided and unguided media. So a guided media is going to be a physical wire, so an Ethernet cable or a coax cable. Okay, guided media is good in that you can see where it goes, you can place it, you have some control over it. Okay, the bad part is that you have to install it and there's more costs. So the alternate there would be unguided media. Okay, unguided media would be wireless or microwave or some other kind of thing without wires. The advantage is it's inexpensive to install. The disadvantage is it can be hurt by physical barriers. It's also hard to control other people from getting on your wireless. So if you have a business that has wireless throughout the business building, then somebody in the parking lot, there's a fair chance they're going to be able to pick up your wireless. Okay, so you just have to worry about those concerns. So we'll talk a little bit about some of the different kinds of connections. Again, as part of your proposal, you'll have to pick a way to connect things. Okay. What you see most common is called twisted pair wires. There are literally two different wires that get twisted up. They all have a bunch of different nodes, little sub wires inside of that. Okay. So they're twisted to reduce interference from outside world and also to keep from leaking information. It's important to know from a security standpoint, if you have access to a twisted pair wire and have the right equipment, you'll be able to read information directly from that wire. So you have to watch that. Okay. We usually have Cat 4 or Cat 5, sometimes Cat 6. The Cat stands for category and refers to the quality of the wire. Okay. Some are shielded, which are called UTP for unshielded twisted pair. Some are those are unshielded, or they're shielded. Cat 6 is more robust and they can be shielded as well. Okay, that's what you typically are going to have between your computer and whatever the next step is, whether that's a router at your house or a switch in a business situation. Twisted pair is cheap, it's easy to install, lightweight, it's easy to make the cables. You can make them yourself with very little overhead. Okay. An older technology is the coax cable. A coax cable is going to be a much thicker copper wire surrounded by all kinds of shielding. Okay. This used to be the way we networked all computers, but we don't do that so much anymore. Your cable TV cable is a coax. Okay, so advantages to that, but the disadvantages are it's a little harder and more costly to install. Okay, fiber optics has become the standard to get from one point to another point. Fiber optics are actually glass fibers that send light. Light is very fast, so they're very high capacity. Fiber optics is also lightweight. It doesn't send out any kinds of waves of information. It's difficult to steal information from an optic fiber cable and all that stuff. The downsides, though, that it's more expensive to install, and it can also break if you don't handle it properly. Okay. Wireless transmissions are really taking over the world. That's where everyone wants to be because of the convenience. And those are the advantages. They're certainly much easier to connect to. If you're on campus at Tusculum, you can get onto the student wireless. You don't have to worry about finding, a cable to plug in somewhere. That can be good. Okay. The problem with that is that everybody can get to that resource. Okay. So certainly, if you have wireless at your house, you want to make sure that you have a wireless router that has good security. We'll talk more about that on Security Day. But you don't want other people getting onto your network that you don't know about. Okay, and you may not care to share with your neighbors, but if they do something illegal, you could be implicated in that because it comes through your router. So you have to be careful about these things. Okay. There's also the problem that it can be difficult in some buildings, some structures, to get the signals through. I've heard that if a building has metal studs instead of wooden studs, it can be difficult. The flooring material can cause some difficulties. Or if there's a mountain between you and where you're trying to get, things like that. Okay, so there definitely are some concerns. Okay, someone just got a message that the sound is cutting out. I'm not sure what that means. Let's see here. Yeah, it looks like the stream quality. Dropped for some reason. Hopefully it's still recording properly. Okay, so again, this is a difficult, new bleeding edge technology. In fact, on the live streaming, it says that it's beta, so that means it's still in testing. Okay, so I'm okay. Some people can hear, some people can't. Okay, so you won't know this, but if at some point the sound goes out, you can always go back and listen to it. Hopefully that will solve things. Okay, so again, with the wireless, you have more security concerns, but it's a lot more convenient. Okay. There are some things in the notes that you can read on that we're not going to talk about because they're not particularly relevant enough to go through. For example, circuit switch versus packet switch networks. You can read about those if you want. Okay. So that's layer one. It's the physical bits on the wire, basically. So now we're going to layer two, the data link layer. Okay. The data link layer, again, is going to accept the bits from the physical layer. It's going to do something with them and send them up to the layer 3, which is the network layer. Okay, so that's its job. So you always have to think about that. Okay, it only gets information from the layer above and below it. Okay, so it only gets information from the physical or from the network. It's not possible for an application to directly access the data link layer. Okay, so some of the functions for this, it provides a well-defined service interface to the network layer. The network layer depends on it to get some stuff done. It has to deal with transmission errors, okay, and it has to deal with regulating the flow of data so that the receivers aren't swamped by the information, okay. So what this job, the job of the data link layer basically is to move information from one computer to another physically connected computer, okay. So the data link layer does not get the internet in one fell swoop. Okay, the data link layer is going to get you to the router at your company, and then a new data link layer session will get you the next one all along. Okay, so error correction is important at this point because errors are quick to, or easy and cheap. We would say cheap in terms of bandwidth to correct. So if I'm sending a message from my computer to the router at my business, okay, if there's an error, I can resend it really quickly. No one's wasted anything much. Whereas if there's an error that is not discovered until I'm all the way across the internet, I've wasted a lot of bandwidth. Okay, so that's important. Okay. Let's see, what else do we care about at the data link layer? As far as the network layer and above goes, the computers are just connected. They don't care how. The how happens at the data link layer. Okay. The protocol here that you see most often is Ethernet. Ethernet. We talk about Ethernet cables. The Cat5 cables are often called Ethernet cables, and you'll have an Ethernet port on your computer, but that's not a physical layer. That's how the data link layer connects things back and forth. Okay. So it's important to understand that the processing at the data link layer, accepting in information and deciding that's either for this computer or not, looking for malformed packets or malformed frames, all that happens on the physical Ethernet card itself. Okay, so that's one of the design advantages of this internet or OSI model. Okay, your computer doesn't get involved, so that means Ethernet cards must have a processor on them, and they do. So if there's a bad connection or a bad frame being sent to your computer, the main CPU of your computer will never see it. It'll be discarded at your Ethernet card, okay, doing the data link layer. Okay. So again, there's some more information in there about ways that the Ethernet protocol could operate. Okay. So we're going to kind of skip ahead here to the error detecting, things we can do to detect errors. Again, you want to detect errors at this level so they don't get propagated across the internet. Okay. So the three ways you can do that typically are through parity checks, through checksums, and through CRC or cyclical redundancy checks. Okay. So all these work basically by converting the packet that you're sending into a series of ones and zeros. Okay. Parity is the simplest. With parity, it basically just adds up all those ones in the total message, and figures out if there's an even or an odd number of ones. Okay, so if I send you an email that ends up with 1,000 ones and zeros, so 1,000 bits. Okay, 1,000's an even number, so my parity bit, if I'm using even parity, would be set to 1. It's an even number. Okay, I send the message through the internet. On the other end, it's going to quickly add those up again. If it gets any even number, it's going to say we're good. Okay, so what parity catches is going to be an odd number of errors. Okay, so an error happens in a strings of ones and zeros if something that should be a 1 is a 0 or vice versa. Okay, so parity helps you half the time. Okay, checksums, a little bit more complicated. Okay, but it's going to basically add up the bits into a different way. Often you'll have like a 16-bit checksum. Okay, so that's going to be all of the message divided into these 16-bit words and then add them up. Okay, so that's a little harder to fool, but there are still going to be certain series of errors that are going to get by that. Okay, the stronger kind of connection, which is kind of beyond what we're covering in this class, is called the CRC, or the Cyclical Redundancy Check. That involves a whole lot more math heavy lifting. Okay, so if you're interested in that, you can certainly look that up. Wikipedia has pretty good entries on these things. And we've got a research paper coming up. You could certainly do that as your research topic. That's reasonable for that. Okay. So that's a data link layer. Its job is to get information from one computer to another computer. So again, the data link layer is going to send information to the wire, or to the out port of the Ethernet card, and saying send this information. The physical layer gets it there, but that management of the physical is the sole job of the data link layer. Okay, happens on the Ethernet card. Now we're moving up the list one more to the network layer. The network layer, it has the responsibility of getting things from one computer to another across the internet. Okay, so the network layer is the first to have global perspective. The physical layer only knows about the wire that it's on. It lives only on that one wire. The data link layer only knows about other computers and other devices that are physically connected to it. Okay, it doesn't know about the broader internet. The network is the first protocol that the network layer is the first of our layers that knows about the whole internet. Okay, so some issues there. We have to have a way to address devices across the internet. Okay, so that's important as well. Okay, so this is the first layer we're dealing with. This is the lowest layer that does this. So the network layer, taken as a whole, and when we talk next week about the networking hardware, you will see that there are devices associated with different levels. So the big thing at the layer 3 is going to be the router. Okay, so a router is a network layer device, a level 3 device it's called. Okay, so the layer 3, when taken as a whole, all of the devices at layer 3 as a whole have to know where everything is everywhere on the internet. All of the paths of each network, and it has to be able to direct packets. Okay, again, that's our email message or whatever broken up into bits across the internet. Okay, all the way across to its destination in the most reasonable fashion. Okay, so it's pretty complicated, no doubt. The network layer uses a store and forward system where you send a packet from one layer 3 device. Your computer has all the layers, so it's a layer 3 device, to a router. A router is just a computer that deals with things up to layer 3. Okay, that router is going to store the message in its memory. It's then going to send it out on one of multiple paths. So typically each router will have certain lines that come in, other lines that go out. Okay, so it's kind of like a train station. The packet comes in, it's going to look at it, see where its destination is, send it out on a different path. Okay, so it's going to keep doing that until it finds its destination. Okay, so it's a pretty important thing. Routing algorithms are important. That's how you're going to determine how things get across this internet. Okay, so those can either be static which means they don't change, which doesn't work except in the simplest of situations, or it's dynamic. The dynamic ones mean basically that as this or that section of the internet gets slower or faster, we're going to send more or less traffic that way. Okay. Again, routing algorithms are beyond the scope of this class. They're fascinating, lots of work being done there. So if you're interested, that's another thing you could pick for your research topic. Okay. So it's important, some things we're going to look at here, the services that are provided to the transport layer. That's the next layer up. It's layer 4. Okay. So the data link layer is going to feed the network layer. The network layer is going to feed the transport layer. Okay. So it's important that any services provided to this layer are independent of any particular router. Okay. There are lots of companies that make routers. You need to make sure that whatever protocol you're running doesn't depend on there being the same kind of router that you have. Okay, that's important. Okay. The transport layer doesn't care about how many routers there are between it and the other end. To the transport layer, there's a magic window that connects it to this other computer. Okay, so all the heavy lifting of the internet pretty much is done at the transport layer. Okay. The address mechanism, the network addresses, have to have some kind of a uniform numbering scheme so we can always deal with it. Okay. So the protocol we use at this layer of the internet is called the Internet Protocol. The protocol suite we use on the internet is called TCP/IP, TCP/IP. The IP part is the Internet Protocol. There are other layer 3 protocols in the world that have been developed. They're not widely in use. What gets used is IP because the internet is so pervasive. Okay, so it's a brief summary here, and again, these will be in the notes. I will be releasing the notes of the design principles when they were putting together the IP protocol. It should work. Should be simple. It should make clear choices. There are often multiple ways to implement a particular feature. Pick one to keep it simple. Okay. You want to exploit modularity. You want to use the layers that exist. You don't want to create things you don't need to. Okay? You want to expect heterogeneity. Heterogeneity means that you can't assume that all the devices are the same. You have to assume every device you hit is going to be totally different from all the other devices. Okay, that's again where the protocols come in. The information to make sure your scalability refers to the fact we're okay now. NAT address. Okay, so basically it allows every device connected to your local router, your home router, to share one real IP address. Okay, so the IP addresses that you, if you look on your computer, look up your IP address, it's probably not a real IP address. Okay, it's probably a NAT address. Okay, that's important because if someone's trying to help you, tech help, well, what's your IP address? If you say 10 dot something or 168 is another one that's fake, that's not a real IP address. That's your NAT address. You'll have to work harder to find the address of your router. Okay, we'll talk about routers more next week, but in general, a router is a device that's on the internet, so your computer doesn't have to be. So it gives you a layer of insulation, which is good. Okay. Again, with IPv6, we're going to switch to 128-bit. So from 32-bit to 128-bit, so there will be tons and tons more addresses available. Okay, but the big trend these days is called the Internet of Things, and it means that many, many devices, like your refrigerator and your washing machine, are going to need their own IP address. Okay, so there's always going to be lots and lots of things. Okay. And it does look like we're having trouble on our connection. Hopefully it's still recording. It says that it is, so I'm going to trust that and go forward. Okay. So the transport layer. We've made it to that. The transport layer has the responsibility of connecting a process on one computer to a process on another. Okay, it relies on the network layer to actually make it across. Okay, so the network layer gets it from the computer you're on to the computer it's heading to. So what the transport layer deals with, let's say I'm in a certain browser window, okay, and I connect to CNN.com. The network layer is going to take my packets, it's going to deliver it to CNN. CNN is going to give me the information that I want, send it back. Well, where does it go? Which browser window does it go to? Okay, which program needs it? Okay. So to do that, you have to be able to identify each process uniquely. Okay. So we do that through port numbers. Okay. So a port number just refers to the particular process. Okay. And those port numbers, there's a list in the notes. Some of those are very common, so you don't have to worry about it all the time. So for example, port 80 typically is for the web. Okay, so if I'm connecting to a web browser, I'm going to connect to port 80, okay, all the time. There are other ones out there, such as port 22 for SSH or secure shell access, port 20 and 21 for FTP, things like that. Okay, so you can look at that list. You don't have to memorize them, but it's important to know that that's what's going on. Okay, so that way, when it gets across the internet, gets to your local computer, the network layer is going to deliver it, saying, here, this is for you, computer. Then the transport layer protocols are going to determine which of the running applications it needs to be sent to. Okay, so we haven't talked about reliability yet, and I should have it at the network layer. The network layer operates at what's called a best effort delivery model, which means that it's going to try to send the message as best it can, but if not, it's not going to sweat it. Okay, so the IP protocol, the network layer IP protocol, is unreliable. If it doesn't make it, it doesn't send it back, doesn't care. Okay, the transport layer has two basic protocols, TCP and UDP. TCP is reliable. Okay, so you may be asking yourself, how do you build a reliable protocol, TCP, on top of an unreliable protocol, IP? The answer is pretty complicated, but in a nutshell, you basically have to check on both ends. I'm going to send you a message. Did you get it? I'm sending you a message now. Did you get it as well? Okay, so TCP is a connection oriented. When you connect with a TCP, that's Transmission Control Protocol. Again, that's the TCP in the TCP/IP protocol suites. Okay, the Transmission Control Protocol is reliable. It builds in information to check the redundancy as it goes along. Okay, so that's important. And how that happens, again, complicated beyond this class. But again, reliability in TCP, really good research topic for your research paper if you're interested. Okay. So again, you have to have the port number correct. The other thing that's important, since it's a connection-oriented protocol, there has to be a way to connect things. Okay, and the way that TCP connects is through something called the three-way handshake. Okay, the three-way handshake starts with the client, this client-server model, sending a request saying, I want to connect to you. The server then says, that's fine, I'm ready to connect. Then the client says, okay, I'm going to connect, let's start. Okay, why the three-way handshake? The three-way handshake is just to increase the chances that everything's good on both ends, and to know that. Okay, if you just had the request sent from the client to the server and the server back to the server doesn't know that the client actually received that message, and it's a real client. Okay, so there are limits to that. You would have to have an infinite number of handshakes in order to make sure it's perfectly okay. But it's been found that the three-way handshake is enough to ensure most of the time that things are working well. Okay? So, again, the TCP does have this ability to give reliable transmission. Okay, so when you're viewing a website, it's going to make it. It uses the HTTP protocol at the application layer, uses the TCP. Okay, because it wants it to be reliable. Email needs a reliable protocol. Okay, so The disadvantage is that it's slower because you have to spend a lot of packets going back and forth error checking, and reliability checking, not just errors. It's not just, is there an error in the packet? Did this packet even make it? Okay, and part of that involves you number the packets. So if I get a 1, if I'm the server, I get a 1, I get a 2, I get a 3, then I get a 7. Well, something's missing, and I'll know that. I'll be able to go back and ask for the packets that are missing. Okay, so there's a lot of overhead there, so it's slower. Okay, most of the internet does that anyway because you need reliability. The other protocol that doesn't have reliability is called UDP, or the User Datagram Protocol. Datagram. Said that funny. The User Datagram Protocol is going to continue the best effort method of the network. I'm going to send it, hope for the best. If it makes it, it makes it. If it doesn't, it doesn't. Okay. So the UDP is used in situations where performance is more important than absolutely getting every bit. Okay. And usually you see that on video streaming applications. Okay. So if I want to stream a video at 24 frames per second, I would rather one of those frames to not make it than to slow down all the frames and make it hard to watch. Okay. The other thing with the UDP protocol, just because there is no reliability built into that, doesn't mean that you can't add reliability at the application layer. Okay. So if you're writing a new application for the web, you have to decide, do I want to use the built-in TCP and not worry about reliability? Or do I want to tweak it and do my own reliability and then use UDP because it's faster? Okay, and you certainly have those options. Okay, so TCP is going to take care of flow control for you, congestion control, retransmission if there's a bad packet, all that stuff because it's reliable. UDP does nothing. Okay, UDP is like opening a fire hose of data and you just start sending it. If it overwhelms the user, too bad. It's the user's problem. Okay, so again, it's for very different kinds of applications. Okay. And there's more detail in the notes on the three-way handshake. There's lots of stuff. I didn't put it in the notes, but it's out there if you're curious. There's, again, think about how the physical network works. It's a series of ones and zeros. Okay, so there has to be a way to divide these streams of ones and zeros along as they come down the wire to know what to do with them. Okay, so there are these little key sequences of ones and zeros that mean different things. As part of that, on the TCP part of this whole stream of numbers, there are different flags that can be set. A flag is like a way to send a specific message to somebody in a very efficient manner. Okay, so that's what the three-way handshake ends up doing. Okay, so that's kind of the OSI model. That's the basic of how the internet works. Okay, so if you have questions right now that you can think of, go ahead and put them in the chat window. It looks like that some people are up and down on the network, which is unfortunate. I see now that I have a connection status that I didn't before. Hopefully that still means that the internet's going to be viewable later. If not sure what we're going to do for a plan B, but we'll do something there. Okay. So again, I'm going to post the notes out there. There'll be an assignment this week that I'll post here in a day or so. I do want you to get started on the group project. Somebody asked the question, can you pick your own teams? I think that's fine to pick your own teams. I don't know how well you know each other. A lot of times you take classes together a lot. A lot of times you're maybe in different groups. I don't know. I don't think there are official cohorts anymore like there used to be. So I will leave it to you to figure your own teams out. If you need help with that, just send me an email. Okay? And we can go from there. Also be thinking about, you can go ahead and start working. Classes are quick. We've got 5 meetings here. So there'll be stuff due on the project coming fairly soon. Okay, so I would go ahead and get together with your teammates and start talking about how you may approach this final project. Okay? So again, I'll post the notes. Again, there's lots of detail that we glossed over today. Okay, so there are no tests in this class. Online tests, I think, are a little bit iffy sometimes. The proof's in the pudding in that if you can develop a good plan, then I'm going to assume that you know what you're talking about. And I know the group projects always have trouble. People may not pull their weight, but we're going to go with it anyway because that's how the world is. A lot of you work already, and you'll know that you cannot avoid group projects in the workforce. Okay. So someone asks, is everybody here in Greenville? I don't think that they are. I don't know. So if you see that, Steve posted that. Yeah, people are answering on the chat, which is the way to go. Okay. Again, I would recommend that you get Google Drive. You already have. If you have a Gmail account, you have Google Drive. It allows you to share documents with your teammates. And that is the absolutely best way to manage these group projects, not just in this class, but in any class. Okay, so basically you create either a spreadsheet or a document, which is like a Word type document. You then go up under the share, edit, share. You can put in the Gmail address of everybody else. I will be putting onto Moodle, and if I forget, remind me. I'm doing a million things these days, so I have to be reminded sometimes. And I don't get offended by that at all. I will put everybody's Gmail address on there, okay? Unless you have a real reason you don't want to, but you kind of have to. Have this for this group project, okay? So you can share with your teammates. Make sure you give them editing privileges. That's one of the options when you share, okay? And when you do that, it means that whoever's made the last changes, even if you're changing it live, everybody can see, okay? So if you need to have a team meeting, which you will, your best approach is to do a Google Hangout with your teammates. And while you're doing that, so you can talk to each other or chat or whatever you want to do, you'll have the document in a separate window that you're all editing on at the same time, okay? And that really is the best way to accomplish this, okay? Are there any other questions on anything? Okay, this again was the network basics. There's lots more out there, okay? And I will put an assignment out there, but we'll say our research project will probably do not next week, but the next week. And I'll put the official write-up. But it's basically just find a topic about networking that you're interested in and do like a 5-page report on it. Okay, it's a new policy in the College of Business, both in GPS and on residential, that we use professional language all the time. Okay, so if you're sending me an email, make it a nicely written, like you're a memo at work. If I send you an email, I'm going to try to make it very professional. Okay, no acronyms, no text speak. No informal language, no colloquialisms. So the same thing with this paper. This paper that we're doing needs to be a formal, written, let's say 5-page document exploring some topic in networking. Okay. So keep checking Moodle. Everything else should be on there. I will send out an email poll, and again, if I don't, remind me, trying to find an evening to have virtual office hours. And we can do that with the Google Hangouts. Okay. I'll give a couple of seconds for that to come through to see if you have any other questions. If not, I think it would be best, since we have a little time left, to go ahead and go to Google Hangout. That won't record, so if you're watching this later, you won't get to see that. But that's just to see if get people that are here on it, and see if we can get the mechanisms of that down. Okay, so I'll wait just a second, and then when you hear this, I'm going to go ahead and stop the stream, and then I will move over to the Google Hangout. Okay, I'm not sure anyone's still listening. I'm trying to get the Google Hangout set up, and it's giving me some trouble at the moment. Do see the email from Katrina and from Patrick, so I do have at least Patrick's Gmail address. Okay, so I will answer those emails as well, but I am trying to get the Google Hangout set up with a little bit of difficulties. But anyway, so I will try to connect at least a couple of you if you're still on.